Small is not the same as zero, and indeed, Canadian astronomer Paul Weird has now concluded that the probability of impact for the asteroid Apophis is higher than previously thought. Essentially, the 350-meter-wide projectile will pass close to Earth in April 2029, provided that its trajectory remains unchanged until then. But that is precisely the crux of the matter. According to Weird, even a collision with a small object could be enough to send Apophis off on an unfortunate path. The fact that we cannot fully assess the real danger at the moment makes the situation no less tricky. Unfortunately, the asteroid will not return to our field of vision until 2027. Apophis holds two records. On the one hand, the asteroid reached the highest value of all time on the Turin risk scale in 2004. On the other hand, as a supposed killer asteroid, it also triggered record-breaking media hysteria. Discovered in June 2004 by Roy Tucker, David J. Tholen, and Fabrizio Bernardi, this space rock quickly garnered unwelcome attention for being on a collision course with Earth on April 13, 2029, a Friday the 13th, no less. The corresponding impact probability was initially estimated at 1 in 37, or 2.7%. This probability applied not only to April 2029 but also to potential future encounters in 2036 and 2068. Fortunately, both the media frenzy and the astronomical threat have since subsided. As a result of detailed follow-up observations, it is now considered impossible for Apophis to come into close contact with Earth in 2029, barring an unexpected event that throws the asteroid off its current course. However, even in the worst-case scenario, Earth would have a lucky escape. In other words, even if Apophis were to collide with Earth, the impact would not unleash a global catastrophe akin to the asteroid that ended the dinosaurs 66 million years ago. At 350 meters in diameter, Apophis is simply too small for that level of destruction. That said, a direct hit would still be catastrophic on a regional scale. According to experts, the impact crater alone would devastate an area spanning several kilometers. The force of the collision could obliterate a region the size of Central Europe. Expressed in figures, Apophis would release energy equivalent to 900 million tons of TNT, 60,000 times greater than the destructive power of the atomic bomb dropped on Hiroshima. While this energy pales in comparison to a global extinction event, its localized effects would be devastating. The exact consequences of an asteroid impact would depend primarily on where it hits. A collision on land would obliterate cities and ecosystems, while an impact at sea could trigger tsunamis over 100 meters high, submerging nearby coastal areas. Despite these sobering possibilities, current trajectory observations suggest that Apophis will pass very close to Earth without incident. To put close into an astronomical perspective, the asteroid will pass at a distance of over 30,000 kilometers, below the geostationary orbit of satellites. Still, the all-clear comes with a small caveat. The asteroid's future trajectory depends on it maintaining its current course. This is where uncertainties creep in. Scientists discovered a few years ago that the Sun's radiation pressure causes Apophis's orbit to shift by about 170 meters annually. While this deviation is insufficient to direct the asteroid toward Earth in 2029, it raises concerns for subsequent flybys. Another potential risk comes from space debris. Paul Weird, an expert in orbit calculations at the University of Western Ontario, warns that even small collisions could alter Apophis's path. Surprisingly, the object striking Apophis wouldn't need to be very large. In 2022, NASA's DART mission demonstrated how the orbit of a larger celestial body could be manipulated by the impact of a much smaller one. The mission involved a spacecraft deliberately crashing into Dimorphos, a 165-meter-wide asteroid moon. While this experiment was a controlled test, a similar collision in an uncontrolled scenario could have serious consequences for Apophis. Even a collision with a small asteroid, the kind that frequently impacts Earth, might transfer enough momentum to deflect Apophis significantly. Given these possibilities, experts are keeping a close eye on Apophis's trajectory. Monitoring missions and improved observational techniques will help refine predictions and identify any potential risks. The key to mitigating the threat lies in early detection. By understanding Apophis's orbit and its interactions with other celestial objects, scientists can devise strategies to address potential dangers. If Apophis were ever deemed a serious threat, humanity might turn to deflection techniques similar to those tested in the DART mission. Methods such as kinetic impactors or gravity tractors could alter the asteroid's trajectory enough to prevent a collision. However, these technologies require years of preparation and precise execution, underscoring the importance of proactive monitoring. As of now, Apophis serves as a reminder of both the dangers and marvels of our cosmic environment. Its close approach in 2029 will provide a rare opportunity for scientists and the public alike to observe an asteroid from relatively close quarters. This event could inspire renewed interest in planetary defense initiatives, encouraging investments in technology and research aimed at protecting Earth from future threats. Apophis's story is far from over, and its journey through the cosmos will likely continue to capture imaginations and fuel scientific discoveries for years to come. Adding to the intrigue of Apophis is the ongoing effort by astronomers to use its flyby to study the Yarkovsky effect, a phenomenon where an asteroid's orbit changes due to the uneven emission of thermal radiation. This effect, caused by sunlight heating one side of the asteroid, can significantly alter its trajectory over time. Apophis provides a unique opportunity to measure this effect with unprecedented precision, offering insights that could help scientists predict the paths of other potentially hazardous asteroids. Moreover, the 2029 encounter will enable researchers to conduct detailed radar and optical studies of Apophis's surface and composition. These observations could reveal critical information about the asteroid's density, structure, and potential weaknesses. Understanding these properties is vital for developing effective deflection strategies. For instance, if an asteroid is found to be a loosely held together rubble pile rather than a solid rock, different approaches may be required to mitigate its threat. Public interest in Apophis has also sparked discussions about the broader implications of asteroid defense. The close approach serves as a wake-up call for humanity to prepare for future threats. While Apophis is not expected to impact Earth, its trajectory highlights the importance of international collaboration in planetary defense. Organizations like NASA, the European Space Agency, ESA, and other global partners are working together to improve asteroid detection and develop contingency plans for potential impacts. In addition to its scientific and defensive significance, Apophis has captured the imagination of the public and media. Its dramatic flyby is expected to be visible to the naked eye from certain parts of the world, offering a rare celestial spectacle. This visibility has led to plans for public outreach and educational campaigns to raise awareness about asteroid science and the importance of planetary defense. By turning a potential threat into an opportunity for education and inspiration, Apophis's flyby could leave a lasting legacy beyond the realm of astronomy. Looking further into the future, Apophis's story underscores the need for continued investment in space exploration and technology. The tools and techniques developed for asteroid detection and deflection have applications beyond planetary defense. They contribute to our understanding of the solar system, support space mining initiatives, and pave the way for future exploration missions. By studying Apophis and similar objects, humanity takes another step toward becoming a spacefaring civilization capable of addressing the challenges and opportunities of the cosmos. In conclusion, Apophis is not just an asteroid, it is a symbol of our ongoing relationship with the universe. Its close approach in 2029 will mark a milestone in our efforts to understand and protect our planet from celestial threats. Whether as a harbinger of danger or a source of scientific discovery, Apophis reminds us of the delicate balance between risk and opportunity that defines our place in the cosmos. The story of Apophis is a testament to human ingenuity, curiosity, and resilience, qualities that will continue to guide us as we navigate the vast and unpredictable expanse of space. Please like, share, subscribe and comment. Thank you for watching my channel.